we will discuss about this problem. In this problem, you have to calculate the response V2 of this two-port network if you give the excitement as unit step input. So if you give the unit step input here, then what will be the response of this two-port network where Z parameter is given? You have to calculate. Now in this lecture I will show you how to solve this type of problem. So first of all, I will write the V1 and V2 in terms of Z parameter. So we will know that V1 is Z11 I1 plus Z12 I2 and V2 is Z21 I1 plus Z22 I2. This is equation number 1 and this is equation number 2. So using Z parameter, I write this voltage V1, V2 in this equation. Now I have to find out the relation between the V1 and Vs. So if I took this loop, this is loop, then I can say that the Vs is given by 2 into I1 plus V1. This is 2 into I1 plus V1 is given by Vs. And I know what is the V1. So in this equation, Vs is given by 2 I1 plus Z11 I1 plus Z12 I2. Now I have given this Vs as a unit step input. So here this Vs is given by as UT as a unit step input. So it is UT and this is 2I1 and this I is as a function of t and this is Z11. So here the Z11 into I1 as a function of t and this is Z12 I2 is a function of t. Now I will transfer it into a Laplace transform into a frequency zone. This equation are in time zone. So you have to transfer it into a frequency zone. That means here the Z parameter is given by into a frequency zone. That means S that means j omega. So you have to transfer this equation into a frequency zone. That means you have to take Laplace transformation. So taking Laplace transform and putting this the value of Z11 and Z12 is given by this. If I take take Laplace transform of this unit step function, so it will be 1 by s equals to 2, and this will be I1 as frequency zone, and this is Z11, so here this is Z11, so equals to 2 divided by s plus 1, and this I1 in frequency zone S, and here is Z11, so it will be 1 by s plus 1 into I2 S. Okay, so this is I1, this is I2, so if I take common I1 S, then it will be s plus 1 into 2s plus 4. This is 2s and 2, and it will be 4, plus it will be 1 by s plus 1 into I2 s, and this is 1 by s. So if you can write this equation in this way, so it will be 2s plus 4 into I1s, and plus it will be I2s. This is equation number suppose 3. Now to calculate this V2, you have to find out I2. So if I take this loop, then I will find out what will be the V2. So it is I2. So V2 can be written as, from this loop, V2 can be written as V2 equals to minus of 1 into I2. So it will be minus I2. V2 is equals to minus I2. You can write from this equation. Okay, this is I1 in this direction. So this is V2, this is minus plus. So plus minus, minus plus minus. So it will be V2 equals to 1 into I2. That means minus I2. Now from equation, this is V2 and this is V2. Okay, so from equation 2 and suppose this is equation 4. So from equation 2 and 4, this is V2 is minus I2. So I can write that from these two equation, we can write that I2 Z21 I1 plus Z22 I2 is equals to minus I2, and this will be Z1 I1, all are in T zone, so that means Z22 I2, this is T, and this is plus I2 in T, this is will be 0. Now taking Laplace transformation, and putting these values of Z21 and Z22, we will get, this is Z21, this is 1 by S plus 1. So it will be 1 by S plus 1 into I1 S plus Z22, that means 6 by S plus 1. So this is 6 by S plus 1 into I2 S, and this will be I2 S equals to 0. Now it will be, this is s plus 1, this is s plus 1. So if I take, this is I1 s plus, if I take common I2, then it will be s plus 7 into I2 s equals to 0. So here this is s plus 1, this is s plus 1. So if I take this as a multiplication with this 0, then I1 s plus 7 into I2 s equals to 0. Now from this equation we can write that I1s is given by minus of s plus 7 into I2s. This is equation suppose 5. Okay, so look this equation number 3. There is a I1. So we have to calculate V2. To calculate V2, we have to know I2. So here this equation number 3 contain I2 and I1, and this equation will gives you the value of I1. So from equation number 3 and 5 we can write that, from equation number 3 and 5, from equation number 3 and 5 we can write that this is s plus 1 by s equals to, this is 2s plus 4 into I1, this is minus, so I have taken this minus here. So this is s plus 7 into I2s plus I2s. So this is s plus 1 by s, this is s plus 1 by s, 2s plus 4, 2s plus 4, this is minus s plus 7. So here I have taken minus here, so s plus 7 into I2s, and this is I2s. This is the equation. Now this is will be s plus 1 by s is equals to, I have taken I2 as a common, and then I will multiply this. So all are will be positive, so it will be 2s square plus 18 minus 18s plus minus 28 and plus 1. Okay, now this will be s plus 1 divided by s equals to I2s minus 2 square minus 18s minus 27. So I2 is given by s into minus 2 square minus 18s plus minus 27, and here it is s plus 1. So if I take this minus on the upper side by taking minus in the lower side, so it will be s into 2 square plus 18s plus 27. Okay, this is I2s. Now we have to calculate V2. Okay, V2. Now I erase this. Now V2 is given by minus I2. So here this is I2. So V2 S is given by, this is minus, so minus minus will be plus, so it will be S plus 1 divided by S into 2s square plus 18s plus 27. So you can write this is this is S plus 1, so this is 2s into s square plus 19s plus 13.5. So now you have to solve this. Okay, so it will be V2s is equals to, this is s plus 1 divided by 2s into s plus 1.902 into s plus 7.098. Okay, so here you can solve into this form. Okay, s square plus 9s plus 13.5 can be written in this form. Now you have to transfer it into a time zone. This is frequency zone. You have to transfer into a time zone. That's why you have to take inverse Laplace transformation. Okay, so that's why you have to written in this form. That means V2s can be written as A of s plus b by s plus 1.902 plus c by s plus 7.098. You have to transfer this equation in this form. Okay, so how to calculate this value A, B and C in this way? So A must be equals to V2s into S into V2s when S equals to 0. This is the, suppose V2s, this is the value of V2s. You can write this equation. This V2s will be, this will be plus, so s plus 1 divided by s into 2s square plus 18s plus 27. Okay, so this is the equation of V2s. So this is V2s into s, so s would be cancel out, so here it will be s, that means 0 plus 1 divided by, this term will be 0, will be 17. So if we take 1 by 17, it will be 0.037, and b can be calculated as s plus 1.902 into V2s at s equals to minus 1.902. If you put this value here, then it will be if you put this value in this equation, then it will be 0.0456. Okay, similarly C can be written as, can be found out that 0.83. Okay, now this equation now can be written as this equation can be written as V2S is equals to, this is a value of A is 0.0, this is 0.037 by S plus 0.0, there will be a minus, okay, there will be minus, so it will be 0.456 divided by S plus 1.902 plus it will be, there will be minus because this value is minus, so 0.083 divided by S plus 7.098 and this is US, okay, this is US, not in this way. So now if you taking inverse Laplace transformation, it will be V2, it will be T. Now this will be equals to 0.037, this is UT, that means 1 by S inverse Laplace transformation is given by U of T, okay. So I have taken as a bracket plus 0.0456, this is e to the power minus 1.902 into T minus 0.083 into e to the power minus 7.098 T into UT, okay. So this is the response of this network when you apply the unit step input of these two networks. So in this way you can calculate the response of a two-port network.